let's see if we can add a little bit more intelligence to that. This leads us to the empirical rule. So here is the empirical rule. And the empirical rule says if the distribution of a variable is unimodal, what does that mean? Well, if we look at the distribution, we get something like this. It's unimodal. There's only one mode. A mode is what's the most popular value. Okay? It's not bimodal. So bimodal might look something like this. You've got a very popular value here and another very popular, locally very popular value there. That's called bimodal. Okay? And this might be an indication that you've got a mixture of two populations in your distribution here. You might have one that's, say, predominantly short and another group that's predominantly tall, and you've got, it's not like a single population, whereas this one is more indicative of a single group. So that's unimodal. Then it says also that it has to be symmetric. So what is symmetric? Well, it's sort of, we looked at this earlier and we said symmetry is like if you draw a line in the middle like this and then you spin the distribution around that axis, you don't notice any difference. So basically it's what's going on the left-hand side is the same as goes on the right-hand side of that axis. So if the distribution of a variable is unimodal and symmetric, so this doesn't apply to everything, doesn't apply to every distribution we have out there. It only applies to distributions that are unimodal and symmetric. Then, here's the magic. Then, the mean, if we create an interval by saying the mean plus or minus one standard deviation, I shouldn't have put the S there, the mean plus or minus one standard deviation covers approximately 67% or 2/3 of the observations. It covers approximately 2/3 of the observations. So here's the magic. We look at the mean, we added standard deviation, subtract the standard deviation, and now we've got an interval, and that's the interval where about 2/3 of the data fall. Now, this is a rule. So what it typically means is approximately 2/3 of your observations. It's not a law. And there, don't forget the two conditions. Okay, so it's a rule. And that's almost like traffic laws in Italy. They are suggestive. You know, the red light means it's sort of suggestive that you should stop at that traffic light. But here, it's a rule. Okay. And if we want to be a little bit more expansive, we could say mean plus or minus 2 standard deviations. And that will capture 95% of the observations. Mean plus or minus 3 standard deviations will capture all the observations. All right? Mean plus or minus 3 standard deviations. This is the value of the standard deviation. It tells you how the data, how variable the data is. Whether it's small or large, it all depends on this interval. For example, the mean plus or minus, how big is the mean plus or minus 2 standard deviations? So it all depends on the context that you're in. If the context is such that this is too large an interval, then the standard deviation is too large. If the context is such that this standard deviation is gives you a small enough interval, then that's fine. So whether a standard deviation is large or small depends very much on the context that you are dealing with.